Hello everyone, my name is Mariam Beljadid. I'm a first-year PhD student in improved threat detection in the maritime sector through the adoption of advanced AI techniques at University Sultan Moulay Slimane of Beni Mellal, working with Mr. Tanush Adil. First of all, I want to thank each member of this international panel for your time and expertise. It is a privilege to discuss my research findings with colleagues from different countries and research traditions. In this presentation, we will talk about automated machine learning for maritime accident analysis in Moroccan water. Our plan is as follows. First of all, we will talk about a little introduction. Secondly, we will about the data and methods. Thirdly, our results, and we will conclude with a little conclusion. The maritime sector remains one of the most dangerous industries due to the hostile and unpredictable nature of the marine environment. Accidents frequently result from a combination of interconnected factors, making the examination of underlying causes essential for efficient prevention. However, manual exploitation of historical data remains limited in effectiveness, especially on a large scale. Analyzing maritime accident data and identifying complex patterns related to it is now possible due to the appearance of machine learning, but it requires deep expertise. AutoML tools occur as a solution for this limit. It offers to automate the whole process of selecting, training, and optimizing machine learning models. It appears like a cure to speed up analysis and equalize access to the benefits of AI-based approach. Now let's pass to the data and methods. Our method follows a four-phase process, starting with the data collection. First of all, we did the report reading. After that, we did the data extraction, the data loading into a Panda data frame. Next, we had the data exploration, where we had the data set structure, the missing values, variable types, distribution of characteristics. After that, the pre-processing, we handled missing values, transforming categorical variables by encoding, standardizing numerical data, and eliminating duplicates and inconsistencies. Finally, the MLJAR Studio automated pipeline, the selection of relevant variables, the choice and training of algorithms, the optimization of hyperparameters, and finally the cross-validation. The dataset comprises 9 important variables, including vessel types, which are artisanal, offshore, and coastal, maritime district, time aspect, and accident consequences. Between 2040 and 2023, 2,167 accident alerts were received and coordinated by MRCC Rabat. Of these events, we can see that 70% concern the artisanal segment, with a value of 1,527 accidents, while the coastal and offshore segments accounted for 28% and 2% respectively, which is 601 and 39 accidents. Now let's pass to the results. To assess the effectiveness of the algorithm developed, we use the weighted average of the precision, recall, and F1 score metrics. In addition to the accuracy measure, these indicators are determined based on the values of true positives, true negatives, false positives, and false negatives for each category. As shown in Table 1 of the individual models, random forest, XGBoost, light GPM, and CatBoost respectively showed the best accuracy, demonstrating robust overall performance. The other models all show lower accuracy than 89% and overall poorer performance, highlighting an insufficient balance in the detection of true positives without increasing false positives. However, the ensemble model outperforms all individual models for all metrics. For example, the ensemble model in the recall we had 86.1, but for the random forest we only have 84.3. Table 2 shows the detailed results of the five-fold cross-validation performed on the ensemble model. The results indicate a generally high and stable performance on all folds. Average accuracy was 92.4% with a minimal standard deviation ± 0.2%. Demonstration the model's consistency in classifying cases correctly. Precision 89.5% and recall 86.1%. Indicators demonstrate that the model is not only effective in correctly identifying accidents, but also in minimizing false alarms. The F1 score, which illustrates the balance between precision and recall, reaches 87.5%. This confirms that the model succeeds in balancing these two crucial aspects, identifying as many real cases as possible without exaggerating perilous situations. Finally, the mean RMSE, which is 1.046 with minimum variance ± 0.002, demonstrates that the predictions provided by the model are consistent and close to the true values. To conclude, in this research, we present the development and evaluations of an ensemble model for maritime accident forecasting, the case of Morocco, which was generated using AutoML methods. This AutoML method generated the ensemble model by merging the predictive capabilities of several algorithms: random forest, XGBoost, light GPM, and CatBoost, each algorithm bringing distinct benefits in terms of precision, recall, and adaptability, while taking into account the limitations of single models, such as overfitting or reactivity to certain data patterns. Thank you for your attendance.